turns out that the key to good software architecture is pessimism, and that's a bit of a different spin than what the industry's been doing.
Welcome back, everyone, to Kodsnack. I'm Fredrik, as usual, and today I have Barry with me. Hi.
Hi, Fredrik.
Who are you? What do you do?
So, my name is Barry O'Reilly. I live in Stockholm, Stockholm's Skärgård, and I am a researcher, consultant, and a trainer of within software architecture. And I run a small company called Black Tulip Technology, which works with consulting and training and research. And I'm just finishing off a PhD in complexity science and software design. And so I bring in the ideas of complexity science into how we design and think about structures in our software applications. And that leads to all sorts of weird and wonderful ideas and conversations.
Yeah, absolutely. We'll have all the links in the show notes, of course, for people. There are a bunch of interesting talks and other material to get into for those who are interested. But yeah, there's so many starting points already.
Yeah.
So you started with software architecture.
I did, yeah. So I started many years ago as a developer.
Mm-hmm.
And so very quickly moved from developing from that to architecture, and climbed the greasy pole until I became a chief architect at Microsoft on the European level.
Wow.
And that was a fantastic run doing those things. And but I was an architect who was very, very careful to never lose touch with technology. So the entire time, as I took on bigger and bigger problems and tried to do different things and get closer and closer to business concerns, which is kind of the natural progression of an architectural career, I was one of the few architects of that generation who said, hold on a minute, I don't think we should leave the code behind. We should keep coding, we should keep close to the code, we should understand the implications of different decisions in the code. And that's been kind of one of the guiding factors in the work that I've done, making sure that architecture stays relevant and stays anchored to the code structures that are the actual deliverable of an architect, rather than a bunch of documents or PowerPoints. It's a structure within code, which is something that's deeply technical, even if it's slightly different to just raw programming.
Yeah, that's interesting now that you say it, because software architect, it almost feels, the mind almost automatically goes, farther away from the code, and it feels like this is something that's sort of drifting off into the atmosphere.
Yeah, and that's unfortunately been a tendency that a lot of architects, if we go back 15 years, longer, 20 years, a lot of architects have encouraged, because it was seen as a sign of seniority, a sign of how seriously you were taken by the business, the further you could get away from getting your hands dirty. And so it tended to influence people, this idea, to try and remove themselves from the code as a status symbol, which leads to someone who's very good at doing PowerPoints and is maybe very good at talking to business stakeholders and all of those things that we have to be good at eventually. But one day they wake up and find that when they speak, their developers don't understand what's actually happening. And that means that the developers then have to start making the technical decisions on the ground, and the two things get out of sync, and you end up in that ivory tower where you have lots of ideas, but that's not what's happening on the ground. And it leads to a disconnect. And I have to say that my mission over the last few years has been to try and solve that disconnect. One of the things I realized was I used to speak at a lot of architecture conferences, and I would look out over the audience and I would see a lot of grey. And I said to people, doesn't it worry you? Shouldn't it be worrying us that there were no young people here? There were no developers. There's no up and coming architects. There's a generation missing. What are they doing? How are they building their systems? And apparently that wasn't a big problem. And I started to become very worried about this. There's some kind of generational shift has happened alongside the agile movement where this kind of architecture that we do isn't being taken seriously. The consulting work that I do is almost entirely involves rescue. So I come in to rescue projects that have caught fire, put out the fires, try to get the thing to work, or sometimes just write a report or stress test an architecture and tell the business people what you have here is good, it's viable, it's workable, or it's not. And in those teams where there was no architecture, where they'd thrown out the old school architects but hadn't developed any kind of architectural skill themselves, the projects tended to crash very quickly in a very predictable big ball of mud kind of way. And so what I started to do was to redirect my energy towards developer conferences and talk about architecture in a way that didn't scare people away, didn't make people roll their eyes and go, oh no, not more of this, old school enterprise architecture stuff, but something that's actually interesting and useful to software developers who to tell them that there is a level of thinking above programming. And when you look up from your IDE, look around, there is a level of abstract thinking that's necessary in order to structure your code. And it's a very, very different skill than raw programming. And it's not something that's easily taught at university. You have to kind of figure it out by yourself. And this was my focus then, to try and bring that kind of thinking to software architects. And it had been my job at one stage to teach architects, to teach up and coming architects. And so in the work that I was doing and trying to put together a syllabus, I started to dig a little bit at what is it that we actually do? What is architecture?
Yeah.
And there's lots of definitions of architecture, lots of stuff that's hard to change, or it's all the big significant decisions. But most of those phrases they don't really mean anything. If you're trying to concretely boil it down to teach someone, it doesn't really help a developer who wants to become an architect when you tell them it's all the stuff that's hard to change. There's not really much they can do with that. No. And so I spent a long time thinking about how do we explain what we do. And I spent a lot of time thinking about how do I explain what I do. And the truth is that we don't actually know what we do. Software architects, there's research that shows this. Software architects can't point back to their old decisions and say, I made this decision because of this. A lot of times it's because it felt right. It felt good. It was gut feeling. There should be 3 components here. It feels completely natural. We don't know where those ideas, those instincts come from. And that is good. It means that you've developed a gut feeling over your career. It means that you have confidence in your own decision making, but it also means traceability is incredibly difficult in that decision making. Yeah. It also means that teaching junior architects is almost impossible, because what do you teach them? You can't teach a gut feeling. That the only way I used to say that the way we make architects in our industry is we just take the best developer we can find, we bring them over to the edge of the cliff, and we just push them in.
Yeah. Good luck.
Yeah, and we come back in 2 years, and if there's someone down there swimming, then we have an architect, and if they've drowned, then we find the next best developer, and we bring them to the edge of the cliff. And that's really how we make architects. And so for a lot of years, my focus was on how can I tell the story of what goes on in the head of an architect in a way that makes sense to developers, that makes people want to engage with this subject, that makes people want to do it, and that solves all the problems that traditional architecture talked about, such as there's a disconnect with business concerns, solves all of those problems, but also keeps the link between those business concerns and the actual code structure, and doesn't allow this fracturing. And even the fracturing that I saw across different roles, where you would have an enterprise architect who would do a certain thing, and a solution architect who would do a certain thing, and would hand over to a software architect. Yeah. And there's just all these layers, and suddenly with layers you get politics, you get bureaucracy, and everyone starts to hate architecture, and everyone starts to ask the question, what if we just had no architecture? Life would be easier. And sure, it might blow up in production, but I'd rather have a blow up in production than another one of these meetings with all these people and their PowerPoints. And so we had to rescue architecture, I think was the mission a few years ago, and make it cool again, and actually give it some substance. beyond cliches and fluffy things, and close this gap, which had opened up between a certain kind of senior architect and software developers who no longer trusted each other, and in some cases at some companies I worked with no longer had even the ability or the desire to talk to each other. So they both worked in little silos, occasionally throwing documents at each other and having angry meetings. And so that's been the focus, I guess, of my last 10 years is bringing together a syllabus, a way of teaching these skills to architects.
I was thinking while you were talking that if it's a sign of the problem, that if someone came to me today and asked if I wanted to take over some kind of architecture role, I'm not sure what they even meant by it.
Yeah.
What exactly would be included in this? What's the context?
Yeah, that's one of the first things I teach. Is that whenever someone says architect or architecture, that you have to immediately ask, what is that? What is that for you? What does it mean in this room? What's your expectation? When you say architecture, is it software structure? Is it requirements engineering, which it sometimes is? Is it drawing processes? Some architects think that they design businesses. And that's a completely different kind of architecture.
Yeah.
And so you have to always ask these qualifying questions. And sometimes you'll meet someone and you'll say, what do you do around here? And they'll say, I'm a lead developer, or I'm a tech lead, or something like that. And you'll scrape a little bit more. What does that mean for you? And you'll find out, what you're doing is actually architecture. But for some reason, you don't want to take the title because it's got those connotations of these old stiff bureaucratic lines and boxes people who get in the way and stop things from getting done. I know it's a trend at hip companies that you don't have architects anymore, but you have this concept of staff engineer.
That I've heard.
Yeah, and you'll find out things like Facebook, and there's much more emphasis on keeping those people closer to the code. I think they may have learned the same lessons I have, or see the world the same way I see, that you have to stay close to the technology in a different way, but you have to stay on top of the technology and understand what it is that you're building and what it is that an architect is actually responsible for in the delivery of software.
Yeah, there's so many aspects. So it's still very much about the context you're in, or each person, each organization.
Yeah, and so one of the things that I teach architects is that there is no magic formula. So this is what architecture is. This is how you execute. This is how you do things. This is the set of tools that you need in your toolbox. Everyone wants just a simple answer to that question. And the honest answer to that question is that every time you go into a project, or every time you go into a new organization, every time you try to do something, you're going to have to build your architectural process as you're moving through it. So you're building the plane while you're flying it. What are the tools and techniques and ideas that I'm going to need to use here to make this work? And that means that sometimes you'll work in a way that's incredibly agile. Sometimes you'll work in a way that calls itself agile, but it just means there's no structure or anything happening. Sometimes if you go into a really large bank, for example, you'll find that it's very traditional. It's very much based on paperwork and sign-offs and checking and double checking. And as an architect, your role is to be able to fit in any of those situations and be flexible enough to still deliver an architecture in sometimes very, very different circumstances. And this is difficult. It takes a lot of experience and it takes a lot of luck to become an architect, because you've got to sort of pinball around in the beginning of your career and get to see enough things to know what's happening where. Whereas if you've been working in one company for 15 years and maybe you've risen to the role of architect, it can be a massive shock to you to change jobs and take an architectural role somewhere else and find out that it's just simply not the same thing because you've changed context. And that makes everything very, very different.
Yeah, to say the least. So I mean, you've consulted in architecture roles in various companies. I mean, considering how different it can be, do organizations know what they're asking for when they ask for an architect? Do they have a thing in mind, or have they heard the label and think, yeah, this is a person that can solve the
Yeah,
problem is.
they generally they don't have a clue, and they don't feel good about this because they know that they don't really understand it. And when they say architect, you have to again, what does that mean to you? You have to ask the question. One of the things I've been doing over the last couple of years is executive coaching. So I'm working with sort of high-level executives talking about architecture and saying things like, so this is what an architect might look like. This is what they can do. You're going to meet different architects who can do different things, who've pinballed around in their careers in different ways. They're going to have different ways of saying the same thing. Some of them will have seen a lot. Some of them will have seen a little. They'll all have seen slightly different things. This is why they're so weird. This is why they, throw PowerPoints at you and run away. This is how to identify an architect who is bluffing. This is how to identify an architect who's too technical, too much in the weeds. This is how to identify an architect who's too fluffy, they've floated away and they're headed for that ivory tower. This is how you deal with consulting architects to make sure that they actually deliver to you and things like that. So for a lot of people inside the business organizations, architecture is kind of a mystery. And one of the things is that sometimes I'll go in, I've gone into customers and they've said, what's the problem? Why did this crash? And I'll look and I'll say, well, you have no architecture. You have no architect. You thought that if we threw all this stuff together, you would have a system and it would just work. And every time you ask the vendor, will this work? They said yes. And you assumed that would be okay. So you need to hire an architect. And then I'll come back 6 months later and they'll say, hey, we hired an architect just like you recommended. And I'll meet the architect. And it's someone who is a business analyst, never built a system in their lives.
Ooh.
And, so organizations don't even know how to interview, how to hire, how to evaluate if someone is an architect or not. And so, if you want to be an architect today, you go into LinkedIn, you change your title. And you're an architect, and that's one of the dangers. We're a self-titling profession, and not everyone has that degree of self-insight to realize that maybe I'm not quite there yet, and that can be very, very dangerous as well.
Yeah, absolutely. There's a lot to sort out in under this label, clearly.
Yeah,
and you've done a lot of interesting work in that, toward that.
Yeah, I think one of the things I started to do, I think, as I reflected back over, what do I do? What's the difference between me, who's doing this successfully enough to be asked to teach the next generation? What's the difference between me and people who are struggling to do it? What's the difference between other colleagues I have who are succeeding? And I spent a lot of time thinking and watching people, and I realized that the difference between the really good architects, the senior architects, and people who were just coming up, people who hadn't quite learned how to do it yet, was that the senior architects were comfortable whenever things were highly uncertain. So one of the things that you'll see that's incredibly difficult for junior architects who are taking their first steps is you put them in a room with stakeholders who don't know what they're talking about. The stakeholders don't know what they want. They don't know why they want it. They can't really describe the problem. They're incredibly vague. And if you put a junior architect into that room, they will become very, very stressed and start to make demands of the stakeholders. They'll demand clear requirements. I've done this myself when I was junior. I'm not doing anything until you write some very clear requirements about what you want, and push the problem back onto the business people, who become very stressed and have a meeting and say, this is horrible. We don't know what we're doing. And they write something to make you happy. But what they write is noise and nonsense, because that's where they're at on their journey. And then you turn that into software and it turns out not to be what they wanted. And where senior architects will go into that room and say, yep, this is how it's meant to be. Business people don't know what they want. Nobody knows what they want, but we can still build an architecture just by having some conversations and pushing them in the right direction. We can gather enough information about what is potentially going to happen in this environment and start to move towards building some kind of solution to a problem, or at least provoking enough good conversations with a piece of software in order to get an idea of what is the problem that we're actually trying to solve here. And that's key to being able to do this job. And so from there, the step in, how do I get these junior architects and senior developers who want to take that step up? How do I get them to be comfortable in uncertainty in dealing with this kind of thing? And that's where a lot of the ideas that I built up over the last few years have come from.
Yeah, and they've come out in what is it? Multiple books and a PhD.
Yes. So one of the first things I did was I realized that uncertainty was the key to being able to do it, being able to handle uncertainty, because I mean, it's the easiest thing in the world, if you're a good coder, to take a finished specification, write some code, make it run, test it, say, here, it works.
Yeah.
It's much, much more difficult to meet business people, stakeholders who don't know what they want, and be able to somehow get that to work in a business environment that maybe isn't even finished. Maybe we haven't even started delivering to customers yet, but we have to have software to support it. We don't know what it's going to do. We don't know what's going to happen. And so I did what I did was I went to Google and I typed in the word uncertainty. And I said, who someone else must have met these problems.
Yeah.
And eventually I came to the complexity sciences, which is an entire scientific discipline dedicated to answering the question of what do we do when we don't know what's going on? What do we do when we're at the edge of our scientific capacity? And when we don't have all the answers, how do we act? How do we solve problems? And from there, through various authors, various papers and ideas, I arrived at a set of ideas that said that the best way to build software is just to design something as quickly as possible, something absolutely awful, and not really care about it, and then just start stressing it until it breaks and falls apart. And then every time it breaks and falls apart, you learn something about how does this thing break, and then you change it so that it breaks in a slightly more pleasant way, because everything will always break. And then you break it again, and you break it again, and you break it again, and eventually you get to a point where you can't break it anymore, and you're what? Well, that's weird. It won't break. And then you give it to someone else. You say, can you break this for me? And they'll, of course, find a way to break it. And then you break it a few more times with their help. And then they reach the same plateau. Like, I can't break this anymore. And then you give it to someone else. And eventually it gets harder and harder to break. And this is the way that I've been doing architecture for a very long time. It was almost instinctive. And, and then throughout my career, I would constantly hear, why are you so negative? Why are you so pessimistic? And why? And so instead of asking for requirements, trying to figure out what the future was going to look like, I was more concerned with, I'm going to build this thing. What is it vulnerable? Where is it vulnerable? Where will it break? What's it sensitive to? How will it crack? And then patching those cracks, finding those fault lines, knowing that they're there, and understanding that this architecture has a way out from doing this. When I talked about this, originally I talked about it through the lens of something called Anti-Fragile, which is a set of ideas from an author called Nassim Taleb. And I started to get some attention when I talked about these things, and people say, come to our conference and talk about this. And then there started to be a lot of people interested. And I thought, well, here we go. Now I'm going to have one of those careers where I stand on stages and talk about things. And everyone applauds. It'll all be lovely. But I thought, and I felt, a lot of times when I was watching other people present ideas in IT, I was thinking, do we have any proof of this? Is this real? Is this real? Or did you just make this up? Yeah. And sometimes I would think this is a very good and very convincing speaker that we have in front of us right now. But where am I? Why should we believe them? What proof do we have? And, if you work in medicine, right? Well, up until this year, because the world's changing so fast, it's hard to keep up with. But previously, when you worked with medicine, you couldn't just stand on a stage and say, this is definitely going to work, or this worked in my house, so therefore it's going to work everywhere else. And that's the way software worked. And I felt like, well, I don't want to actually do that. I don't want to just get up and say, look, this is the way I do architecture, and if you do it my way, it'll be really good. Because I couldn't make that statement and be sure that it was true. So I decided to go back to university. I decided to turn this into a PhD. I said, look, so I went to a university. I said, I have these ideas, and I want to beat them up, and I want to put them through peer review, and I want them to come out the other side either saying this is rubbish, it was a nice story, but there's nothing there, or this was something real. This is a real idea that holds up to a scientific test. And I'm nearing the end of that journey now, and so the ideas did hold up to that scientific test. They work, and it turns out that the key to good software architecture is pessimism. And And that's a bit of a different spin than what the industry's been doing up
Yes.
to now.
Yes.
And it's just, if you're negative enough, you will eventually get to a design that holds. But there's a few very specific ways we have to do it. We have to be a little bit random in our thinking. We have to be incredibly creative in the way we think about this. It's not enough to just be negative. You have to be negative in a very colorful way. And now that it's been shown that those ideas work, I wrote a whole bunch of academic papers, and I would talk about them, and I gave them out to developers. And people were very interested in the ideas because it's kind of it's a new thing, right? To have an idea in our industry, but also to put it through that kind of mincing of academic criticism, which is really, really difficult. You know, you spend a few years being shouted at for you're not allowed to use that word because you haven't defined it, and you haven't defined this. You're not allowed to talk about that. You haven't read this paper from 1936, so don't even open your mouth. And it lifts the ideas up very many levels, but it's a painful process. And one of the pieces of feedback I got then from developers was, we can't read this. It's way too dense. It's way too heavy, because everything has to be qualified. Everything has to be referenced. Nobody can make it through that kind of a document. And so last year, there's a conference it used to be in Amsterdam. It's going to be in Antwerp this year, called Domain Driven Design Europe. And at Domain Driven Design Europe, they said, can you write us a little book that we'll give out to all of the attendees of this conference? And and I thought, well, this will be a good way for me to practice writing in a way that is accessible to developers instead of scary and too academic. And so I wrote this little book. I started to write it, and it ballooned to about 200 or 300 pages. And so I sent them an email saying, it's going well. It's about we're on about 200 or 300 pages, and they sent me a very panicked email back going, like, we don't have budget for that. We meant like 16 pages, like max 24. I was like, I remember I was giving a keynote at a conference in Munich, and I woke up at 7 a.m. in the morning. After the keynote, I had a day off. I was supposed to be traveling home, and I got a text message from Lufthansa who said, look, we're on strike, so, good luck. and I'd gone to sleep the night before, and I was thinking, I'll send them an email tomorrow, and I'll say, look, guys, I'm sorry. I can't get this down to 16 pages. It's not going to happen. It's not going to happen in these time frames. And I took up my phone, and I thought, no, you know what? Let's just start writing and see how far this goes. And it took me a very long time to get home, so I had to fly from Munich to Oslo, from Oslo to Stockholm, a lot of dead time. So I spent the whole time just with my phone in my hands, typing furiously. And when we touched down in Stockholm, I was like, the end. And and then they had said to me, max 24 pages. And I was like, well, I overshot a little bit, right? We're on 34, but we're in the realm of negotiation now. Yeah. But it turned out that was 34 pages that I had written in Microsoft Word. That turns out to be 70 pages in the little booklet. But eventually, after a little back and forth, we compromised on 74 pages, and so the book got released.
Wow.
So we decided we were going to do it, and I started tidying up the book, and I got my kid to do the cover art, and then I started getting emails, right? Because the rumors started spreading that this book existed. I started getting emails from people saying, hey, I'm not going to this conference. How do I get a book? And so the first email, I was like, you can't. You have to go to the conference. And then I started getting so many of them that I started looking at, well, how do people do this kind of thing? What's the best way to release a book? And I went to Leanpub, and I thought, okay, I'll put it up here. So I put it up on Leanpub, and I thought, there we go. That's solved. Put a little post on LinkedIn. I went to bed. I woke up the next morning, went into Leanpub, and the book was at number 1. And I was like, okay, this is totally unexpected. Yeah. And it turns out that these ideas that I've been having, and there were a few videos floating around from NDC, the Nordic Developers Conference in Oslo and other places, and this had kind of caught people's attention, and it's exploded ever since.
A quick but huge thank you to everyone sponsoring us on Ko-fi. You can become one of them by surfing to ko-fi.com/KODSNACK and giving us either a one-time donation or a monthly support. If you support us on the coffee drinker level of €5 per month, you get a bunch of very nice stickers in your actual mailbox. If you support us on the barista level for €10 per month or more, you also get a big thank you right here. Huge thanks to Michelle, Albin Groen, Anders Legell, Brother Ingo, and Tobbe Lundberg. Everyone who supports us helps make this podcast possible. And the more of you there are, the better we can make the pod. We do sometimes have sponsors, but it's actually your support which is making it possible to cover our monthly costs on a more regular basis. And if you want to support us in other ways, you can of course give the podcast a review in your podcast player. Give it a thumbs up, a star, write a comment, or whatever else your player supports. Or simply tell someone who might like the podcast about an episode. Oh, and there's also a new way to support us. For the first time, we have a sticker for sale on Ko-fi. Show your support for safe practitioners everywhere with our set of 3 Agile Release Train Engineer stickers. But remember, you are a fantastic person, whether you support us or not.
One chapter in the book was called The Philosophy of Architecture. And that was one of those pages that, one of those chapters that I thought this will be a couple of pages, and it went to 200-300, just the chapter itself. And the reason I was even thinking in this way is because when you're doing a PhD, you have to write a chapter that says, look, this is my philosophical position. This is how I look at the world. Yeah. And so I took those 300 pages out, and I thought, you know what, I'll have to sacrifice these. I'm not going to get this into this booklet. So over the last 6 or 7 months, I've been working on these ideas. I turned them into a little talk about the philosophy of software architecture. I gave a few talks on it and noticed that architects in any case liked it. And then I went and I gave the talk at a developer conference. I think the first one was DevSum in Sweden. And so DevSum called me and said, can you come and do a talk? And I was like, oh, yeah, okay. And what do I have lying around? I have this philosophy talk. It's dangerous to talk to developers about philosophy. They'll all fall asleep. They'll think it's boring. But they liked it. And so I started, just daring more and more. And eventually in June this year, I spoke at NDC Oslo again on philosophy, and I thought, well, it'll be okay. They'll stick me in some tiny room way at the back, and a couple of people will turn up, and it'll be fun. And they put me in the big room. I turned up, and I thought, this is going to be embarrassing because there's 400 chairs in here, and there's going to be 4 people. I'm going to listen to that, and it's going to be weird. And at the end, we filled the room, and there were people standing in the aisles and at the back, and people loved it. And I thought, wow. So I did not realize that people are going to find this philosophy stuff interesting, but it turns out there's a hunger out there for a new way of thinking about architecture, and the philosophy stuff really does give people tools to start looking at their own thinking and their own ideas. So that became massively popular, and I gave the same talk at NDC London last week, and on Thursday I released my new book, The Architect's Paradox, which is just basically mirrors the journey of philosophy from ancient Greece to today, with the journey of software engineering from Babbage through Turing, von Neumann up to where we are today with the cloud, microservices, and all of those things. And that book is at number 1 in the charts. So I just found out an hour ago that it's number 1. The first book is still at number 5. So, wow. So the challenge has been raised: is can I get a third one into the top 10?
Yeah.
And so these ideas seem to have struck a chord.
Yeah, absolutely.
With the industry, despite the fact that this is so different than anything that's been talked about before in terms of the approach, the way of thinking, the kind of ideas that I'm using to build software architectures are kind of radical, where I'm using random simulation of the environment, where you can use random words to generate an architecture through storytelling and things like that, that produces much more resilient architectures than what you would get otherwise, despite the fact that originally a lot of enterprise architects and established architects found these ideas very scary, very different. And there was one talk I gave to enterprise architects in London where honestly it was in a cinema seating, and if the seats hadn't been welded to the floor, I think they would have thrown them at me. Wow. It was I think that what I've struck upon here is a way to talk about architecture that's comfortable for modern software developers. And I think that gives us hope for the future, that there is going to be a future where architecture and software can work, so architecture and programming can come together again to produce something rather than being two silos that don't really trust or understand each other, and that we hopefully won't let them drift apart ever again.
Yeah, I mean, from my point of view, it feels like there's a lot of thinking that ties in with how we would like to think ourselves of like agile developers and doing lots of iteration and stuff like that. It connects very naturally to that. And I can imagine if previous architecture thinking was much more structured and rigid, that it's quite a shock to the system.
Yeah, it is, and it sort of puts me in the middle of things where there are still architects who think that I'm extremely agile, and there are lots of agile people who think that I'm extremely rigid. And sort of that's that nice sweet spot where, you know, if I'm offending people on both sides of this, then I'm probably in the right area.
Yeah, I'm onto something.
And so the emphasis is on, yes, you can have agile software development, but there's still a need for architecture work to be done. But that doesn't have to be done by a centralized committee. Architecture can actually be taught to almost everyone who works with code, can learn how to architect, and it's not something that you have to skip. And it's not something that involves very long meetings and lots of PowerPoint. Architecture is actually a very technical skill, which has to be learned separately from programming because it's a different kind of thinking. But it's not something you can teach to anyone, because you have to be a programmer first. You can't teach this to someone who hasn't coded and hasn't suffered and doesn't understand what's there. And that statement alone is actually incredibly controversial for an entire generation of architects. There'll be lots of chairs being thrown as soon as you say that you need to understand how code works, how it compiles, what it's like to debug, why software structure matters to the behavior of a system and its environment, and that's considered controversial by some. And some people think that it's controversial that I say that you have to think about the structure before you actually build it.
Okay.
They would rather just build something and see what happens, which will get you to the same result, just much more painfully and much more expensively.
Yeah.
So it's about trying to find that balance.
Yeah. So, I mean, I'm thinking from my side as a coder or developer, it seems really appealing because this says that there are tools and a sort of a good way for me to take my knowledge and sort of expand or move up in other levels and take more things into consideration, sort of widening my ability to reason about things and build stuff. It seems really exciting in a new way. But do developers have any kind of opposition? Is it that it seems too rigid to them sometimes before?
I find that they say that to convince people of your idea, you need to have 25% of the room with you. And I find that I have usually 95% of the room with me. And so there's another 4% who are quiet and they're like, I'm not sure if I like this. And then there's that very vocal 1% that's trying to unscrew the chair from the floor so they can throw it at you. And the people who don't like these ideas tend to be very rigid thinkers. They have a very specific way of working. And sometimes some of the things I'm saying are maybe very threatening to them. So perhaps they're very good coders. They think linearly. They're very good at that logical thing. And I'm saying, look, if you want to take the step up to the next level, it's not about getting better at writing code. It's not about writing faster code or better code. It's about learning how to reach out to people and understand what is the context that this code has to run in. And there's no rigid algorithmic way to do this. It's very, very poorly defined, and you're going to have to define it for yourself every time. And you're going to have to understand what your business does. You're going to have to understand how they make money, and you're going to have to understand who they compete with in their market and how that contributes to the internal company culture and how all of those things turn up in your code. And for some people, I think that causes a great deal of stress in them, and you get a little bit of pushback then, and they say, we don't want to do this, or we shouldn't have to do this. But the vast majority of developers have the same reaction as you. Here's a way for me to step up a level in a way that's understandable, that's still incredibly technical, but allows me to make contact with that world that up until now has been kept away from me in a silo by people who draw lines and boxes and show me the lines and boxes, but don't allow me to touch the world that's over there. And that I think a lot of developers find that really exciting. One of the things that happens is I used to run courses in this, and I would get a lot of senior developers would turn up on the advanced course and say, show us how to do this, build a system whenever there's no requirements and we don't understand what's going to happen. And I'd say, well, you've got to start by understanding the business model and where that can move. A whole lot of them couldn't do that. And that felt very foreign, very far away. So I ended up creating another course just to teach that kind of thing so that they could then come in and do that. And then I discovered that there were a lot of enterprise architects who were starting to come to the course. And so I said, right, well, okay, you're quite good at understanding where the business model shifts and how that might affect the code, but they're absolutely hopeless at then changing the code to make sure that it copes in the changing business model. So I had to create another course for them that went into the guts of distributed systems and queues and cloud and all of the stuff that you have to do to build modern systems. And so I ended up with this 3 different courses that take people all the way from a developer right up to a senior architect who's able to work in extreme conditions of uncertainty. And this and so there's a stepping point for most people then. And what I tend to find then is that, for very senior people, they'll come along, they'll take the courses, and they'll say, "Yep, this is exactly what I've been doing, but I wish I'd taken this course 20 years ago." But what the course gives them, because they already figured it out, it gives them a vocabulary, a way of describing using these models and networks and things from the complexity sciences to describe what it is that they do as architects.
Yeah, I mean, that's such a big thing, getting words to put onto things you sort of fumble after we could never really express in a...
Yeah. And so one of the coolest things was in one of my workshops, I had a guy from Microsoft who built some really big stuff in Azure. It was a program manager for some really big stuff. And he was speaking at a conference, and he had some time to kill. So he came and sat in the back of my workshop, listened in to teaching these ideas. And at the end of the workshop, he said, this is how we build the big stuff. This is what we actually do. We don't have your big fancy words for all of this, is what he said, but this is what we do. This is the way you have to think to build big, nasty things. And that's fantastic validation. So I've managed to describe what it is that senior architects do in a way that gives them a vocabulary, but also allows us to much more easily teach junior architects. And like I said, most of my work is in Project Rescue. And Project Rescue is absolutely horrible way to make a living, because you come into a project and everything's on fire. Everyone's unhappy. Everyone is blaming everyone else for what's going wrong. And then I come in and they all look at me and they say, whose fault is it? And then I have to say, well, it was kind of their fault. and then they get really angry. And then I say, but it was also a bit these people's fault. And then they get really angry, and you end up with just everybody hates you, and that's why you charge so much for these kind of projects. And what I realized then when I had these ideas, this way of teaching architecture, I went into a project one day, and I just thought, I can't be bothered with the politics here. I can't be bothered with this circus that we have to go through every single time. And so I said to them, look, this is what's going to happen. I'm going to come in, I'm going to write a report, I'm going to say whose fault it was, everyone's going to hate me, I'm going to leave. Then you're going to do something, probably not very much. In 6 months' time, this project, after you restart it, will be back in the ditch. You're going to call me and you're going to say, hey, it happened again. Can you come and tell us whose fault it was this time? I said, so the better thing to do is that I take everyone away from this project who's involved. I put them in a room together. I teach them how to do architecture properly. I teach them how to question their own architecture, how to test it, how to make it work. And then we'll send them back in and they can figure out where the fault is and they can figure out how to fix it. And maybe with a little bit of guidance. And that turned out to be a much, much more constructive way to solve problems in these large organizations, because not only does it solve the problem, the immediate problem, it also gives you a team who now actually kind of know what they're doing around architecture, and that they have a sense of confidence, they have a sense of being a team, rather than being naughty people who get told off for not doing things right. And so that has been a much more effective way to solve that particular kind of problem. And there's, as you know, there's plenty of failing projects out there. So
yeah, I've heard.
So it does give results, where they're needed most in the industry as well.
Yeah.
I think that there's a lot of stories in the newspapers right now about certain projects, and some people might feel very bad about that. But the truth is, if you look at the statistics in our industry, failing projects aren't this massive surprise, right? It's a normal part of software development. And so it's natural. If you have a very large company and you're running 100 software projects, that large company, then at least 20 of them are going to be in serious trouble. And that's the normal state of the industry. And it must be terrible to be on one of those projects and have it splashed across the newspapers.
Yeah.
And so I think that there's room for a bit of empathy in these things as well. But also I think the key to solving that problem is education, because most of those big failures are happening because the architecture is failing. It doesn't scale. It's not secure. It doesn't perform. It has threading issues. All of these things are architectural concerns.
Yeah.
And those can only be fixed by education. They won't be fixed on social media.
Yeah.
And so something has to be done there to solve that problem. There's a huge gap between the number of software projects, the number of complex software projects there are out there, the number of architects who are capable of delivering them is much, much smaller than the number of projects. And so that's the problem we need to fix.
Yeah, I mean, there was a mini aha among the other ahas there when you said you teach architecture to all the people in the team.
Yeah.
So, oh yes, it's not one person over there who should have the vision. Something. We should learn.
Yeah, it's really important especially when you have a crashing project, to have the project manager, some people from the business side of things, so that you can point at them and say, look, this is why this doesn't work. And who makes the decisions in a software project? In an ideal world that some architects talk about, they make all the big decisions. That's absolutely not what happens, because you don't have time. And sometimes the project manager is making decisions, the business is making decisions, and the developers are absolutely making decisions, small decisions every day that contribute to the architecture. Nobody talks about it, and it becomes a mess when all these decisions don't really line up. And so getting people to understand their role in architecture, and what they can expect from architecture, and when they need to communicate, and when they need to just make a decision and move on, that kind of thing is really, really important. But architecture is something that happens at a group level. Now you can have, it's always a good idea to have one person who is the architect, who's in charge of making sure that all those decisions are being made, going in the right direction, ultimately responsible for quality. But decision making can't ever be one central person. That's a way to hurt that person and hurt the project and slow everything down.
Yeah. So it's a lot about spreading the information and discussing things, I guess.
Yeah.
So I mean, it's a good thing, good thought as well there. Like, I can't do architecture on my own if I'm part of a team.
Yeah, it's incredibly difficult to do that old school model of there's this one architect making all the decisions. It can happen as an architect that you're left there completely alone. No one else is thinking those thoughts. No one else wants to do it. But and in that case, then your job as an architect is not just to build and design the system, but also to think about what's the next project going to be like. Who can I lift up? Who do I complain to so that we can hire maybe someone else who can do these things? But architecture always needs to be expanding. We always need more people who can do this. And so the kind of architecture work where you shut developers out, you shut other views out, is incredibly unhelpful. It might be helpful to one person's career at a particular point, but it's incredibly unhelpful to the team, to the project, to the wider company to do that kind of thing. And I think people do that when they're new in the role without realizing that they're going to burn themselves out doing that as well. It's not possible to carry the can for every single decision that's got to be made in a software project.
Yeah, and I think so. It's so amazing that you've done all the work to verify and do this the academic way, checking that things actually work. Are there more people doing stuff like that in software? Because I really feel like you said before, that we did this thing once, and now we talk about it as if it's the right thing to do for everyone forever.
Yeah, there is some stuff that is based on academic research. There's a book called Accelerate. It comes from IT Revolution, which was based on proper research, but it's few and far between. I actually heard a podcast once where they were talking about me, and they said, yeah, he's gone back to university, he's doing a PhD to prove that the ideas work, and the other person on the podcast said, "Oh my God, has he really? Do you know what that means? If he does that, we're all going to have to do that. And,
I hope so.
We're never going to be able to just get on a stage and say what we think without having to back it up. But he's going to ruin the industry."
Won't that be dark?
Yeah. I think that what I've done with the way that I've done this, I'm obviously incredibly proud of it, but I'm also aware that it's incredibly difficult. And I've been lucky in that I've been exposed to the right kind of projects and the right kind of problems in order to even be able to have these ideas. And then I've been able to combine my work with the research and be able to eat while I'm doing the research, which is a huge problem and a reason that people don't do these kind of things. I think that it will become more popular, hopefully, and maybe this will be a trigger to get other people to look at their practices, look at what they're doing, and maybe think a little bit more rigorously, and maybe think before they get on that stage and say, this is absolutely the best method that's ever been invented and everyone should use it, whenever there's nothing to back that up with. It would be lovely to see that change, but I'm not going to hold my breath either. I mean, it's an enormous industry. It moves incredibly fast, and sometimes new ideas come from nowhere. And there's an advantage in being the first person to do something, and a disadvantage in waiting for the academic papers that prove that it actually works. But this more academic way of thinking about what we do, bringing what we do back to scientific principles, I think is long overdue.
Yeah.
And I think that the friction we talked about between architecture and the agile movement is a long, slow collapse of a paradigm that I call the engineering paradigm, which came in 1968 when we decided that software development should be engineering, and we should borrow the tools of real engineers who build bridges and aeroplanes and all that stuff, and we should use their tools and be rigorous. And that hasn't really worked for us. And the agile movement was a reaction against that. And what is left of architecture and enterprise architecture today is the kind of fringes of that long, slow collapse. And it's time for a new paradigm. It's time for a new way to think about how we do these things. I think that these ideas are well placed to come in and perhaps contribute to that whatever that new paradigm will be in some way. Whether they are actually the new paradigm or just a trigger to a different way of thinking remains to be seen. But it's exciting times.
Yeah, absolutely.
Architecture is on the cusp of something. We're not quite sure what, but you can feel it in the air.
Yeah, that's good times to be to be involved and see where it goes. No, I just remembered it was an episode long ago I think we recorded at Öredev with someone. He called this age we're in now in software development the golden age of tomfoolery.
Yes, that's a fun.
So I'll find the link for that, of course.
Yeah.
But he was certain that I know. Not too long, we'll all start getting more structured and start figuring stuff out, how it really works, how you do software properly. And I feel like doing research surely must be part of trying to move in that direction, finding things that you actually can build on rather than just going by gut feeling.
Yeah, I think there's a kind of imbalance in our industry. There's a disconnect between academia and real world software development. What I find is that if I'm in a room full of software developers, they'll give me cred for doing the academic thing, for doing the research, but they won't really, maybe not as much cred for writing code or building systems. It's the research that gives you the edge. When I sit in a room full of researchers, they don't care about my research. They're like, he's from the real world. He's built stuff, and
it's exciting.
This guy can step through code. I've been lucky to walk both sides of that. It's very, very difficult to do research. If you're stuck at a university, you don't have access to real world projects. And even if you're given access to real world projects, you're still kind of annoying everybody by buzzing around and getting in the way of work being done. And in the real world, you can't really do research because you don't have access to enough projects. You're stuck in you have to deliver. And I've been lucky enough to find a way to balance, to walk both those tightropes over a period of a few years. And that's given me an incredible level of insight into both sides of this coin, why both of them are actually both very difficult and have a hard time supporting each other. And so that's one of the biggest challenges that we have to solve. And so to make academic research more relevant to software engineers and also software engineers have to play their part and actually read academic research and take an interest in that. And part of that means that when someone gets up on the stage and says, this is the best method that we've ever used, I want to see developers shouting, prove it.
Yeah, exactly. Measurements.
Set the bar a little bit higher, demand a little bit more. And the whole industry would shift if we could manage to bring that change.
Yeah. I mean, I sometimes feel like there is some kind of researcher's mindset or something like that. That kind of mindset that gets people, like you did, go and do a PhD on something, or retire, spend 6 months thinking deeply about one problem, and it's not something all of us do. But I feel like, as someone who's not doing that, there's something I could learn here. There's something I could pick up here to sort of get my thinking in a different mode.
Yeah, absolutely.
Yeah. I guess we're sort of running out of time.
Yeah.
Time flies. This was super interesting.
Yeah, cool.
Is there anything you want to add at the end?
I don't think so. I think I've talked enough.
It's been great.
No, I'm like I said, the books are out there for anyone who's interested. I live and work here in Sweden. I'm incredibly active here in Sweden, so I work together with Dataföreningen and Dataföreningens Kompetens to bring these courses that we've talked about. If anyone's interested in those, and the mission there very much is to create a new generation of architects who can work at this level that we're talking about, and hopefully that should lift, give us a lift across the board, and make architecture less of a solve this problem with modern architecture that we've been suffering. For a very long time. But apart from that, I don't think I have anything more to add. I could talk all night, but I won't.
We'll just have to make more episodes. Yeah. Thank you so much, Barry. This was fantastic.
Thank you, Fredrik.
Tack för att just du lyssnar på Kodsnack. Om du vill stödja oss, varför inte tipsa en bekant om podden? Eller lämna en recension i till exempel iTunes eller något annat ställe där det går att sätta betyg på poddar. Du kan också stödja oss genom att köpa oss en kopp kaffe på Ko-fi, ko-fi.com/kodsnack. Alla pengar går direkt till att göra podden bättre och trevligare. Du kan också komma och hänga i vår Slack-kanal. Länk finns på kodsnack.se, precis som alla andra länkar och all annan info kopplat till varje avsnitt. Sist men inte minst finns det också en länk till vår Spreadshop-butik där du kan köpa tröjor och andra prylar med Kodsnacktryck. Återigen, tusen tack för att du lyssnar. Vi hörs.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.